Good afternoon, everyone. We will be getting started here shortly. Just give people a chance to join us, and we'll get going. All right, everyone. Well, welcome to the Lake Erie Tribs and Chagrin River Watershed Advisory Committee meeting. This is the last of the WAC meetings for the fall of 2021. My name is Jeff Jowd. I'm a watershed team leader with the Northeast Ohio Regional Sewer District, and we thank you all for joining us today. As we move forward, if you have any questions, please feel free to go ahead and put those into the chat box. Keith McClintock, the manager of Watershed Programs, will be monitoring that for us, and we'll read those questions aloud and we'll get those answers. We will be posting the presentation on the district's website like we always do, but if you have any specific slides that you need, please reach out to me or your other watershed team leader. We have a great agenda for you today. We have Matt Sharver, the Deputy Director of Watershed Programs, providing us with a welcome and an introduction, and I'll provide you with some updates. Then we have our feature presentation from Justin Tellup with our WQIS group on Plum Creek fish relocation. Some very interesting stuff there. We got a strategic support update, master planning update, inspection and maintenance update, design and construction updates, and then a look ahead. So I'll go ahead and pass it over to Matt Sharver, Deputy Director of Watershed Programs.
Hi, good afternoon, everyone. Thanks for attending. And on behalf of Frank Greenland, our director, I just want to extend the thank you. Frank's out of town at a conference, so that's why he couldn't join us today. But I just wanted to cover four areas briefly, just to highlight for you all. As Jeff mentioned, Justin Tellup, who is an environmental compliance inspector in our water quality industrial surveillance work group, is going to provide a pretty interesting presentation today. And he's first up on the list about a fish translocation project in Plum Creek. And I think you're going to enjoy it. And I hope you are able to pay close attention to try to understand the broader picture over the decades that the district and our partners, which you all are our partners, have begun to uplift the water quality in Plum Creek. And now we have an opportunity to improve the water quality standards for Plum Creek. So it's going to be a good presentation. I hope you enjoy it. After that, as Jeff mentioned, George Remius, who's our manager of stormwater strategic support, is going to paint another picture for us in terms of how we're trying through the stormwater program, make a concerted effort to address local system issues in concert with our regional system improvements. So hopefully that'll be providing some insight into that program area. And then we've got some development occurring on a dashboard for our members that will hopefully make our community cost share and other grant programming processes easier for you to access information. Perhaps we might be able to even roll in the reimbursement process into that for those grant programs. So that is under development and possibly be rolled out in the coming year here in 2022. And then lastly, I just wanted to mention in terms of our grant programs, I don't think we have any slides today with specifics, but our member community infrastructure grants program had another successful year of awarding $15 million worth of project to member communities. So it's never too early to start thinking about infrastructure improvements for that program. We can certainly, the watershed team leaders and others here at the district can help support thought processes going forward for pending applications. So we expect that for the next couple of years, we should be able to provide $15 million worth of funding annually. So we look forward to working with you on successful applications. So with that, I'll turn it back over to Jeff. Thanks.
Thank you, Matt. So community cost share as it stands in 2021, sewer district sitting on $32,489,000 roughly dollars that need to be spent by our member communities. 22,000 of that is available. We got another, or 22 million. We got about 10 million that's already been approved and accounted for. As you can see, 2020 was kind of a down year for the use of community cost share funds, which is to be expected with COVID. 2021 is looking pretty good, hoping to overtop what we did in 2019. So please keep thinking about how you're going to use those funds to help with stormwater issues within your community. If you have approved projects out there and you've completed those projects, please submit your reimbursement request. We want to get that money back out to the member communities. And there's a handful of communities out there that need to spend their year 2 funds by the end of the year. And so I will be reaching out to you, but let's start thinking about how we can all use the community cost share funds to help address some of the stormwater issues within your member community. All right, the LSSES, or the Local Sewer System Evaluation Studies. So most of the member communities that are going to be here today in this WAC meeting, your LSSESs have been complete in the Heights Hilltop and also in the combined. So those community reports should have been sent out to you. If you didn't receive them for whatever reason, please reach out to me and we'll get those out to you, but you should have gotten them already. The Mill Creek Interceptor, the Cuyahoga Valley Interceptor, and also the Southwest Interceptor, they're reviewing those final community reports and those will be sent out shortly. So we have a few updates on the stormwater fee credit manual. So this one, previously the quantity credit applied only to lots that drained to stormwater control measures, even if that stormwater control measure was built to account for all the lots. In that scenario, only some houses or condos in the HOA would receive the credit, even if they all paid into the maintenance. So we are changing that so that all of the sublots can get the credit as long as that stormwater control measure was designed to account for them. So this is a little bit of a change here, but we want to acknowledge those that are paying into the maintenance of that stormwater control measure, just trying to give folks some more credits as they pertain to them. All right, another update that we have. So currently we have industrial NPDES quality credit that allows companies to get a 25% credit for complying with their permit. We will be copying that program over to service municipalities that with MS4 NPDES permits. So currently public buildings like city hall, service yards, police stations are exempt from the fee, the stormwater fee, but there are some situations, some self-sustaining buildings uses such as maybe pools or municipally owned daycares or rec centers where they are not exempt from the fee. And so what we're looking to do here is that those will be eligible, those uses for the quality credit, through the MS4 NPDES permit. So if you have any questions about this or any of the other changes, please reach out to Chris Hartman. He'll be able to address those questions. So just a couple of other updates to the policy. Credit eligibility will require an applicant to at least have partial or shared maintenance responsibilities for an SCM. This wasn't the case before, but we wanted them to have some skin in the game, if you will. So going to require that partial or shared maintenance for the SCM, the stormwater control measure. We are also going to be adding an expedited credit application process for stormwater control measures that are funded through the Green Infrastructure Grant Program. So just trying to speed up that process as they're submitting a lot of that information through the grant program already. Credit renewals. So we're going to limit the dates on some of the credit renewals from May 1st through December 1st to ensure that SCM inspections can be completed during favorable weather. So we don't want an inspection to come due in January when it's snow covered and we can't really see, you know, how that stormwater control measure is functioning. So we're going to try to align those with better weather for those inspections of the stormwater control measures. And then there's various administrative updates to provide additional clarification for those that are reading the manual. If you have any questions on any of these changes, feel free to reach out to me, your other watershed team leaders, or Chris Hartman. So the raft tool, as we like to call it, the report a flood tool. This is a newer tool. It's been out there for a little bit. You know, we've talked about this before in the past. This is live now. We've got a lot of communities that are using it. We have over 300 inputs into this tool. So this is where we'd like you to go when you have flooding, whether it be basement, street, or yard flooding. We want to get all of those reports into one central database, and we can help you with that if you need help on how to use this tool. And if you need to get information out of this, please reach out to me or the other the watershed team leaders, and we can go ahead and export out some of this data for you, because this is supposed to be a beneficial tool, not only for us, but also for our member communities. So please, let's make sure that we're reporting all flooding that's occurring on this raft tool. It's a really great thing. So we have some new branding here at the district, a new mark, same message. So please note this, this new branding that we have going on. Here it is. This is the logo that you would use on a dark background. We can get that out to you. So if you are using our logo for any of your publications or presentations, please make sure that you reach out to me and I'll get you the proper logo. Again, this is white that you would use on a dark background. The next we have the dark logo, which you would obviously use on a white background. So just streamlined it. I think it looks great. Let me know if you need it. We'll get it over to you. Here is the watershed team leader map. I am in the cool dark colors. Those are all of my member communities. We also have Donna and Myring out there. And if you need a copy of this map, we can go ahead and get that out to you. But it's always good to know who your watershed team leader is. All right, so this is a picture from our Brook Stabilization project over at the Cleveland Art Museum. This was a great project in which we were able to provide Brook some access to its floodplain, provide some meanders in there, and stabilize some erosion that was negatively affecting the art museum and its driveway up at the top of the hill. So this was a great project for us. Keith, do we have any questions that came through the chat?
We do not.
Okay, well, just remember, folks, if you have any questions as we move forward, please go ahead and put those into the chat. and we will address those as we go. I am very happy to hand it over to Justin Tellup. He is our Environmental Compliance Inspector too. He's got a great presentation, and I'll go ahead and hand it over to him. Go ahead, Justin.
All right, thanks for the update, Jeff. Yeah, my name is Justin Tellup, work in the Environmental Assessment section of our Water Quality and Industrial Surveillance Department. Here to give you an overview of a project we're doing in Plum Creek, and we're looking to translocate fish upstream of the waterfalls you see here with the overall goal to support biological attainment in the stream. But first, to give you some background on the stream, Plum Creek is a sub-watershed to the Rocky River watershed, empties into the west branch of the Rocky River near Olmsted Falls. And the sewer district is responsible for 3.6 miles for our stormwater management program, basically right before it dumps into the west branch of the Rocky River. Just some characteristics of this watershed for Plum Creek. It drains about 18 square miles, which is pretty big for a headwater stream. The cutoff for that's 20 square miles approximately. 27% of the watershed is forested, 20% urban or developed land, and really only 4% is impervious surface, which is really good for a stream in our watershed in our service area. So now some background on how Ohio EPA does or assesses their water quality standards. Everything that Ohio EPA does is biological for the state. So water quality standards purposes, we have two components for headwater streams. We have the fish component, which is measured by the index of biotic integrity, and the macroinvertebrate section. That's the second part, which is the invertebrate community index. We also take physical metrics. We take the QHEI, which is the qualitative habitat evaluation index, and we take water chemistry. So those really are to support biological attainment, to where if we're not meeting our biological attainment, we can rely back on our physical or chemical parameters to see what may be causing that impairment. So the table to the right here lists all bioassessments that have been done on Plum Creek, first one dating back to 1981. And what I have highlighted here for you is a bunch of nons. That means that is in non-attainment for the biological criteria in every single assessment dating back to 1981. So prior to the 90s, Ohio EPA did work on there, and they listed the causes of non-attainment as gross organic enrichment due to poor chemical water quality. That really got cleaned up in the 90s. Moving into the 2000s, they listed a new impairment as nutrient enrichment. And currently, dating back to 2014 to current, there is no real cause besides natural sources in the stream. So how do we get all that cleaned up in Plum Creek watershed? Well, the organic enrichment portion was really taken care of with a lot of part due to the sewer district. In 1983, we started planning our Southwest Interceptor expansion, which the Southwest Interceptor is a really large sanitary sewer. It collects all the local sanitary sewers and brings them over to our southerly wastewater plant in Cuyahoga Heights. So when that Southwest Interceptor finally went online in 1997, it took off 3 wastewater treatment plants out of commission. It took the Brentwood, the Western Ohio Utility, and ODOT Park 339, and a total of over 500,000 gallons a day of treated wastewater, which really wasn't treated very well. Now it's out of the watershed completely. There's currently 1 wastewater plant remaining, which is the Plum Creek wastewater treatment plant, which has an average design flow of 0.04 million gallons a day, which for comparison, our southerly wastewater treatment plant averages over 100 million gallons a day. The nutrient enrichment portion of the impairment was really taken care of by Ohio EPA and partners. So when a stream is impaired for nutrient enrichment, Ohio EPA goes in and they created a total maximum daily load, or a TMDL, for Plum Creek specifically in 2001. So what that did is it made Plum Creek wastewater treatment plant report their nutrient effluent, so what's coming out of their wastewater plant, put limits on them. And in 2019 and 2020, monitoring by the sewer district showed that Plum Creek's now meeting all of those total maximum daily load target criteria that Ohio EPA put in place back in 2001. I think this figure here really shows how you can recover the watershed biologically. Dating back to 1981 and 1982, Ohio EPA did complete watershed assessment on the Rocky River watershed, which is shown here in 3 different time frames. So the left figure shows really half the watershed is in attainment, 51.7%, with most of the impaired sites in red and yellow being in the lower reaches. That's within the sewer district service area mostly. And most of that was caused from wastewater treatment plants within the watershed. Moving forward, 1992 to 1997 is the middle figure. You really don't see much improvement. We go up 1.4% in attainment. And 1997 is really when those wastewater plants started to become offline, tributary to that southwest interceptor. So the figure to the right here shows the total of 9 wastewater treatment plants that the sewer district took offline with the introduction of that southwest interceptor, took all that flow out of the Rocky River watershed, and we really see a really nice biological recovery, especially in the main stem is now at a complete recovery for their water quality standards. East and West Branch are meeting. You see the few streams left are streams that had wastewater treatment plants that are red, and they have some type of physical barrier that's preventing those fish from migrating back upstream. So we'll start with the first component here, the macroinvertebrates. These are the aquatic bugs that live in the river for their whole life or part of their life. 3 pictures here are kind of what they look like. They're very small, usually less than 1 inch long. So we measure biological criteria with macroinvertebrates in a few different ways. The top left figure here shows total taxa per year. So the more taxa you have per year, the more biodiversity and the healthier your stream is. And really after 2000, you see a good increase in biodiversity within the stream. The bottom left figure shows sensitive taxa. So these are bugs or macroinvertebrates that can only live in good water quality areas. And there wasn't hardly any of them prior to 2000. And since then, we're getting them in almost every assessment we do on the stream. The figure to your right, EPT taxa, these are the families that are really sensitive to pollution. Not all the taxa within there are sensitive, but they're good indicators of water quality. And we're seeing a lot more of them per year, especially after 2000. And actually, dating back to 2014, 5 of the last 6 assessments have been in attainment for the water quality standards. Now, the second half of that water quality standards is the fish community. Fish are a little different than bugs. The macroinvertebrates are bugs. They spend part of their life in the water, they'll hatch, they can fly upstream. No waterfall or physical barrier is going to stop them from reaching a good water quality stream as long as it's close by. The fish community, as you can see in the top left figure here, has been poor to very poor in every assessment, basically, dating back to 1981. And when a stream is impaired, it can be due to a few different reasons. First, it doesn't have good enough habitat for the fish to live in there in good numbers, diversity, which the figure on the bottom left, we're seeing good to excellent habitat based on our qualitative habitat evaluation index scores. So that eliminates that. As I mentioned earlier, our water chemistry is good. We really don't have any water quality standards exceedances in that. So it should be able to support a good biological community, especially in terms of fish. And the figure here on the right really wraps up what I'm trying to say here. The blue dots would be small headwater streams, less than 20 square miles, tributary to the Rocky River West Branch, without a fish barrier. 5 of the 6 sites that are within that West Branch sub-watershed have some sort of physical barrier blocking these fish from getting upstream, and they had wastewater treatment plants discharging to them in the past. So that is looking like the main cause for impairment here. And this is what we're dealing with. This is at the confluence of Plum Creek and the Rocky River West Branch. This is really the start of a series of waterfalls. It goes to a really high gradient cascade, which a fish that's 2 to 5 inches long really can't swim up against that current. It's just too much for them. So these natural barriers prevent fish migration upstream. Ohio EPA has already issued a total maximum daily load. So when a stream becomes impaired, Ohio EPA puts it on the list, reports it to the US EPA, and they come up with the total maximum daily load, which they did for Plum Creek. So once that's done and meeting all the criteria, it has done in Plum Creek, it's pretty obvious that this waterfall here is preventing fish from getting back up there. So since that's the case, they've also said that Plum Creek's potentially eligible for an aquatic life use redesignation to a lower water quality goal. So they'll change it from warm water habitat to modified warm water habitat. They're going to review it in 2029. If things don't change, they will go through with that. And some negatives of that is it'll lower the water quality protection for Plum Creek, specifically dissolved oxygen standards, habitat goals, and ammonia concentrations that are allowed to be released to the stream.
Hey, Justin, I got a quick question for you. So other streams in the service area are out of attainment. So why did Ohio EPA propose this for Plum Creek and not other streams?
Yeah, really good question. So Ohio EPA this is really a unique stream for them. I don't know if I've ever seen this proposed on any other stream in Ohio, but the water chemistry is back. The water quality is good. It's showing that it should support that fish community. And most importantly, the macroinvertebrates are back. The aquatic bugs are doing well there. They've recolonized the area. They're meeting what the goal, that water quality standards goal that Ohio EPA has put out. It's pretty obvious that this natural waterfall has prevented fish migration, and it's really just an urban stream or a suburban stream with only 4% impervious. So this is really the prime candidate for a project like this to start.
Thank you.
So what Ohio EPA also proposed in there is that a seeding of Upper Plum Creek with the representative collection of headwater fish species from adjacent waters should be considered. If whoever does this project, which we actually took it up, is successful, it'll contribute to the aquatic life use restoration and eliminate the need to lower its water quality goal. So when Ohio EPA proposed that, at the sewer district here, we really talked it over and decided that this project aligns well with our water quality and resource management focus area of our strategic plan. This project identifies an opportunity to drive water quality protection and enhancement on Plum Creek. We've already solved numerous water quality issues on the stream. We've taken the wastewater loading away from it. As Jeff mentioned earlier, our local sewer system evaluation study is nearing completion out there. We're going to continue to improve water quality. It's just the free fish migration that's hindering its potential to achieve full biological attainment. So now that we have an idea for this project, we have to get into the process of starting to implement that. And that starts with the species selection. We were really specific on which species we wanted. We ended up coming up with a list of 9 candidate species, and they're selected based on the following criteria. First, they've never been collected in Plum Creek before. Second, they're found in abundance in adjacent waters to Plum Creek. So these are fish that would have likely migrated back up if not for the waterfalls. Third, they have the ability to increase the IBI score, which is the index of biotic integrity, or the fish component. And the figure here to the right shows the 9 species on top with the 12 metrics of the IBI score. And all the positives you see here are positive attributes to each metric. So all these species are going to improve that score if they're successful in spawning and can survive in that stream long term. We cross-referenced their spawning habitat preferences and what's available in Plum Creek. So we took the qualitative habitat evaluation index, what substrates are there, is there woody debris, and then what are the needs of each one of these species in order to reproduce successfully. And then these are really just typical species that should be found in Plum Creek. They're found in other West Branch headwater streams. So these are good candidate species to start this project with. So now that we have our species selected, now we have to come up with a plan to move them into Plum Creek. So all of our source locations that we're using to gather these fish are going to be from within the Rocky River watershed. We didn't want to translocate these fish across watershed boundaries. They're not likely to swim across watershed boundaries in real life. And our goal is to put a minimum of 200 fish per those 9 species into Plum Creek for 3 years at 2 seed locations. The figure to the right here shows our 2 seed locations. We have one at about 1.5 miles up the river and one close to 3 miles up the river. And they're our typical monitoring stations anyway. So we'll go back there in the future and see if those scores are going to improve. The benefit of translocating these fish for 3 years is it reduces environmental variability of a bad spawning or weather year. If we have a drought, an extremely hot summer, and some of these fish die, it's not likely to happen for 3 years in a row. So doing that for 3 years in a row really eliminates that environmental variability. We're increasing genetic diversity as well. We don't want inbreeding within these fish that causes deformities, erosions, all sorts of other bad things within the fish community. And then we're increasing the number of fish that we introduce, therefore increasing the chance of spawning success. All these fish are going to be translocated in the spring. We wanted to get them in there before they spawn, because if you concentrate them in these 2 seed locations where we've already verified there's good habitat for them, the likelihood of them reproducing right away and increasing your population right away increases. Every fish that we put into Plum Creek will get a visual implant elastomer tag, and then we're going to perform a fall sampling every year to determine survivability, or if they're reproducing within the stream and if they're moving throughout. So as I mentioned, the visual implant elastomer. You don't hear very often around here using fish tags, but this is really a visual tag. So the benefits of this is we're going to color code each fish per year. So 2021 got the hot pink color, as you can see over here to the right. And the benefit of that is you can determine long-term or multi-year survivability success of these fish in Plum Creek. So if we come back in 2026 and we're still seeing fish with a pink stripe, that means these fish are happy there. They're living there throughout their life period and they're reproducing. We can also determine recruitment, or if they're spawning successfully within the stream immediately upon fall sampling. So we get an immediate result whether these fish are spawning or not. Since none of these fish have been collected in Plum Creek before, every fish that we collect without one of these tags is going to be documented as offspring of one that we reintroduced. That's another good benefit of this tagging process. And then we can also document movement throughout the stream. I mentioned we have 2 seed locations. One seed location is getting tagged on the right side of their body, and the other seed location is getting tagged on the left side. These fish move naturally throughout the stream, and we'll be able to tell if they're staying in one area or they're moving throughout the watershed, which we want to see. So as for progress, really our planning started late fall last year and into the winter. And we were able to get this project started in March. We wanted to get started early. That's when the darters begin to spawn in April, March. So we got out there, we completed everything before, or I believe June. But a lot of this was done due to our partner agencies and people who were able to get input from this project. Brian Zimmerman, he's here with the White Bucket. He's really one of the Ohio fish experts. He's a co-author of a Fishes of Ohio book. He works for the Ohio State University Museum of Biological Diversity and has done many of these projects before, trying to expand the range of endangered or threatened species of fish in Ohio. We've also had review of our study plan from Ohio EPA Ecological Assessment Section. Those are the people who proposed the project. And we're hoping someone like us would pick this project up and do it. The Division of Wildlife reviewed our study plan. They're approved it. They're excited to see the results, and then Cleveland Metro Parks as well. And they even gave us permission to use the Rocky River main stem and the Emerald Necklace or Rocky River Reservation as a source location to collect the fish from.
Hey, Justin, I have another question here. So were there special permits that you had to get to relocate fish from one watershed to another? Because I know in other scenarios that we haven't been able to relocate fish, for fear of spreading parasites or invasive species from one watershed to another.
Yeah, we had to get a few permits for this, actually. One permit we get every year for our biological monitoring is our scientific collection permit, which is issued through the Division of Wildlife. That gives us a permit to conduct our electrofishing, keep some voucher specimens, and basically do our biological monitoring. The second permit we had to get is also from the Division of Wildlife, which is a permit to translocate native non-sport fish. So none of these fish are like largemouth bass, smallmouth bass, or anything that would be sought after from fishermen. These are just natural fish that live in Ohio. And in our permit we applied for, we had to state that none of these fish are going to have any deformities, erosion, eroded fins, tumors, lesions, or any type of parasitic disease that could be spread throughout the watershed. In other cases, like you're talking about, most of those fish are common carp or goldfish, and the Division of Wildlife really doesn't like those fish either. They're non-native, they're kind of exotic and don't belong here anyway. So they don't want you translocating fish like that.
Thank you, Justin.
Yep. So as for progress, I mentioned we started in March. We completed our spring sampling on May 15th, and we were able to meet a lot of the goals that we set out at the beginning of this project. 6 of the 9 species, we were able to meet that 200 individual target mark. And for a total, we translocated 3,367 fish with the visual implant elastomer tag in them into Plum Creek. This is a good start. We're excited to get back out there. We're actually scheduled to go back into Plum Creek later this week to see if we can collect any with the tag. And if we are able to do that, you know, this project is really going to start to be a success. So just want to bring everything back to our overall goals of this project. Our goal is to achieve full biological attainment in Plum Creek. So it's already meeting our macroinvertebrate section. The other half, the fish section, we're working on. So if we're able to bring the fish community score back into attainment, we will have eliminated the need for an aquatic life use redesignation to that lower water quality goal that Ohio EPA is going to look to do in 2029. The figure here to the right really shows a simulated score assessment. We took the fish that we collected on September 4th of 2020, and then we added numbers of fish of our translocation species and typical numbers. We took the median number that we find in headwater streams, and we ran a new score. So from our September 4th, 2020, that score was 22 in the poor narrative. In order to get into attainment, you have to have a 34. And our simulation shows that we can get that score up to 46 if every one of these species is able to reproduce and survive in that stream long term. We wanted to shoot a little high. We don't know. I mean, this is kind of a pilot project in Ohio. Ohio EPA is looking to see how this does. They may implement this on a large scale statewide effort. We wanted to shoot high. If we can achieve a score of 34 on the fish community IBI, on the table here on the bottom left, we already have an ICI, which is your macroinvertebrate component, score at a 34. That's an attainment. And for the first time ever, Plum Creek will be in full attainment. We won't need to lower the water quality, and then we will have enhanced water quality and drive protection on Plum Creek for years to come. So Plum Creek is kind of unique. It is a rural stream, 4% impervious. It's a good candidate to try this project on for a first time. But there's other streams within the watershed that have these fish barriers. It's a very common theme throughout our service area. Blodgett Creek here is another one to the west branch of the Rocky River. Even a little waterfall like that, that's a foot tall. That's a mighty jump for a 5-inch minnow. Blodgett or Big Creek, that's a Cuyahoga River trib. And then we have a couple natural falls out on the east side with Brandywine Creek and Mill Creek. So we have to do more research on that to see if the communities are different upstream and downstream of those falls. And then this project, if we're successful or not, is really going to drive future projects like this throughout the district. So here's us on a warm April day on the west branch of the Rocky River. This has been a very fun project to do, to plan, implement. We've partnered with a lot of other agencies, and we're excited to get back out there to see how these fish are doing within Plum Creek. With that being said, does anybody have any questions or comments for me?
I do not see any posted.
All right, thank you, Keith. Well, I'll turn it over to George Remius, who is the manager of Stormwater Strategic Support. Thanks.
Hey, Good afternoon, everyone. I've got two topics I'm going to be covering with you today. The first one is related to how we're using different types of data to support our urgent storm event response. And then the second one is how we are taking these stormwater master planning models and extending them further into the local system to support addressing local flooding problems. Next slide. So you've heard us talk about in other WAC presentations some of the steps that we take as part of our urgent storm event response. And so related to the different types of data, we have an array of data types that we use, and we'll be talking about those here the remainder of this presentation. First one is obviously rainfall. We have two different types: rain gauges, our district rain gauges and other rain gauges, and then our gauge adjusted radar rainfall, which covers not only the area in our stormwater service area, but what also drains into it. We'll be talking about that as well. A number of different level sensors and flow monitors that we have, both from the USGS, our district, and then an external vendor that supports us as well. And then we also have a series of trail cams that collect photos that we can turn into videos to support us with both debris, flooding, and erosion. Next slide. So with the district gauges, we now officially have 30 district rain gauges scattered throughout our service area. We collect with them 5-minute data time steps of the amount of rainfall that records. And we've created a tool that we can quickly extract that data, summarize what is the peak rainfall amounts for a series of durations, ranging from the 5-minute to 48-hour, and then comparing that to a couple of different reference recurrence interval sources. The first one was from the Huff and Angel Rainfall Frequency Atlas of the Midwest, who prepared recurrence intervals between the 2-month and the 100-year. And then the more recent NOAA Atlas 14, which has recurrence intervals from the 1 year to 1,000 year. The example that you see here on the left, the table shows the 30 different rain gauges and the peak rainfall totals that were generated and compared to those different sources. And you can see, for example, the very bottom rain gauge from Westlake, that the peak rainfall amounts were relatively mild, meaning a small intensity storm event between the 5-minute and the 1 hour. But for the larger period of time, the peak 12-hour and 24-hour, it met the 5-year recurrence interval, indicating more of a heavy rainfall. The figure on the right is also something we pulled together that shows just the cumulative rainfall total, and we compare that to the 24-hour period, just to get a sense of when the rain event occurred and just how it accumulated. And you can see once again at the top there, that Westlake cumulative rainfall total exceeding that 3 inches, meeting that 5-year 24-hour metric. So when we have high intensity events or heavy rain events, we have different locations that will go throughout the service area, and we use this rainfall information to help us target where to go. Next slide. Similar to the district rain gauge data, we have since middle of 2016 been collecting this gauge adjusted radar rainfall data, or GAR data. It covers a little over 1,300 square miles, and each of that square mile, of 1,300 square miles, we've broken into 1 kilometer by 1 kilometer grids, which translates into 3,410 grids, collecting similar to our rain gauge data, 5-minute time step data. And we use that data similar to what we do with the district rain gauges, where we compile it, look at the peak rainfall amounts, and get a sense of what kind of storm occurred where, and use that to assist us with where are the high intensity heavy rainfall events. This is an example on the right of the July 12th, 2021 event. This shows the peak 30-minute rainfall totals for the service area. And you can see the areas where the orange is the heavier rainfall versus the darker green is lighter, or if it's clear, it didn't meet the 2-month metric. So there's an example on the far left where there's some orange grids that just so happens to be in Plum Creek, the same sub-watershed that Justin told you about, indicating there was some high intensity rainfall amounts. And it just so happens we have a USGS stream monitor there on Plum Creek, which is that figure you see in the upper left of the figure. And you can see based on that, the levels met actually a flood stage where we ultimately then use that to send out a field crew to assess the flooding situation. So this is something that we do for each of our urgent storm events. Next slide. So in regard to the monitoring data, we have 80 different stream monitors that are located throughout the service area. About 40 of those are USGS stream monitors, and then we also have some district monitors installed and an outside vendor that's also been installing a couple of dozen monitors throughout our service area. And each of those we, if we can, with the online data, take a look at and understand where do we have flooding and use those flooding indicators to send field crews to assess the flooding. And based upon the severity of the flooding, we might prioritize where we would go first versus other locations. One of the things that I really like is how the National Weather Service has defined 4 different types of flood stages. You see them on the bottom left of this slide: action, minor flooding, moderate flooding, and major flooding, where the action stage kind of reflects when the water has reached a stream where it's about to get out of its banks and access the floodplain. Minor flooding indicates perhaps a local road has been overtopped. Moderate flooding indicates generally that there are some buildings that now have been inundated, as well as some roads. And major flooding would indicate a significant area is now underwater with several buildings and several roads. And by having those flood stages defined for the different monitors, then you quickly assess where, what type of flooding is taking place, how severe, and use that to prioritize where to send crews. The example here on your right with the table from that July 12th event has some examples of those USGS monitors with the different flood stages. And there's a couple that Plum Creek, Olmsted Falls indicates for at the time that we collected the data that the peak rainfall at the time was close to, but did not meet that flood stage at the time. But we would send the crews out there because of how close it was to the flood stage. We have defined most of the monitors with this National Weather Service equivalent flood stage, but our goal is for all 80 of those monitors to have these values to help us understand where flooding is. Next slide. We have a couple dozen trail cams scattered throughout the service area as well. These trail cams are generally placed in remote areas or areas where there's either frequent debris accumulation or some type of flooding that we like to monitor. The example here on your left is actually a picture of the trail cam at the airport debris rack. You could see in the instance of this, once again, July 12th event, that the water had actually overtopped the debris rack, and you can see the debris piling up on the upstream side. A picture like this gives us an indication just how high the water got, and then we'd also send off our maintenance crews to go clean the debris here once it lowered to a safe condition. Picture on your right is a trail cam of our Lakeview Dam, and from that you can see from this September 23rd event how high the debris had accumulated. And once again, another example, by quickly pulling up the trail cam, noticing the level of debris, we would be able to send a maintenance crew to go respond to that as well. Having these different trail cams here, once again, we can also collect those photos and translate that almost into a series of videos, so you can see how the water both rose and then had fallen after the storm event. Next slide. So by compiling not only the rainfall data that we talked about, the monitoring data and the trail cam data, that sediment debris accumulation that we would have captured with our field crews, any additional field observations, as well as customer and media reports that report a flood tool that was mentioned earlier on, the more that can be populated, the more it helps us understand what kind of flooding took place for all these events. Then we can use that to help us understand with analysis what kind of rainfall event took place, comparing some of our stormwater models, which we'll talk about here shortly, of what it predicted the flood to what was actually recorded to make sure there's good correlation. And then sometimes we also like to just collect this data, help us with historical storms, comparing them overall to understand what kind of rain event leads to what kind of flooding within each of the different streams, as well as debris accumulation. Next slide. So the next topic I wanted to talk about was how we're taking these district stormwater models and beginning to extend them into the local system to assist with addressing some of the local flooding issues. Right now, the district has over 40 different stormwater models that which are shown in the figure to your right in terms of those different polygons. And each of those we're trying to make sure are managed to reflect existing conditions and the current recommended alternatives to help mitigate the problems that we've discovered. And upon request, these models can be shared with the different communities. Just need to contact us and we'll be gladly share those models with you. And then at times we are reached out to by the different communities to assist with the local flooding problem. And once we agree to do that, we will assist you with addressing some of those different problems. And I've got an example for that here on the next slide. So one of these areas that we're currently assisting the city is an area in the city of Brook Park called the Khalida Ditch. This is an area that was significantly developed in the post-World War II era, primarily in the 50s and 60s. It's about a 4 square mile area. Unlike Plum Creek, which is very little imperviousness, more than 50% of this area is impervious. And because of the time that it was developed, very few stormwater control measures exist, which means that little of the stormwater runoff is being managed currently before it gets into the system. And many of the streams have been culverted. The storm sewers that were built during that 50s and 60s era are primarily still there. Many of these neighborhoods have common trenches in our area. That means both the storm sewer and the sanitary sewer are in the same trench. And many of these pipes, compared to today's conditions, are generally undersized and near the end of their useful life. Next slide. So just to show you how quickly this area developed in that post-World War II era, the picture on the left shows you the area that was developed back in the 50s. And you can see back in 1951, most of this area was generally undeveloped. Whereas the picture on the right, which is in 1979, less than 3 decades later, most of this area was almost fully developed. And you can see the number of roads and consequently the different buildings and the storm sewers that were built to support that neighborhood back in the day. Next slide. Now, the challenge, of course, is, as I talked about, building in that period of time, very few stormwater management regulations existed. And so, but this community is not unique. In fact, it's very common across most of the communities in the state of Ohio, particularly in our stormwater service area. So this graph here shows the population of Ohio. You can see the population, the vertical axis on how high it was, and then the population over the decades. And below that, you can see the different types of stormwater management requirements that were typically required at that time, both the pipe capacity, any floodplain regulations, and whether stormwater control measures were required. And you can see going back to that 50s to 60s era that no floodplain regulations were generally required or stormwater control measures. And the pipe capacity that was used, the size, the street storm sewers were generally smaller than today's standards. In fact, it was around 1980 that really FEMA floodplain regulations came into effect, stormwater control measures for flood control, and then stream setback and water quality volume really started closer to 2000, 2003. And you can see the population of Ohio post that 1980 period, which is a much smaller percentage. So most of the infrastructure in many of our communities are similar to what the city of Brook Park in this Khalida Ditch area is experiencing. Next slide. So in order to support some of the analysis, the community originally had some locations that they wanted to put some detention basins and said, as part of this request, how would this help mitigate some of the flooding in the area? And did the district have any other suggestions? And so realizing based upon what our existing model was, and where it loaded different catchments and what kind of pipes and streams were in the model, we realized we had to do a lot of additional extension into the local system to assist with that. In order to understand some of those challenges that I talked about with the storm sewers and the stormwater control measure potential locations, we decided to do a fairly significant extension in the local system. But by doing that, it'll help us better understand these local flooding problems the community was trying to resolve, as well as some opportunities to mitigate those problems. And so the table on your right gives you an idea of the number of model catchments the original model had. And with this update, how many additional model catchments we provided. So we went from 76 catchments to a little over 1,000. And the catchment size on average was 33 acres, which was actually a very good level of detail, but we extended it down to the catch basin level or the parcel level in the non-residential areas because of the types of solutions we thought would be most beneficial for this area. From a modeled conduit segment, we went from a little over 50,000 lineal feet of pipe modeled to nearly 250,000 lineal feet of pipe modeled. And to give an example of what that looks like, the next couple of slides can help explain that. So the figure on your left shows you the catchment delineations in the original master plan model. And so you can see once again, the average catchment size was around 33 acres, which was very good. But in order to address the local flooding issues that we wanted to assist with the community, we ended up doing a much higher refinement. And once again, to better understand at the catch basin level or at the non-residential parcel level, what kind of runoff was being generated. Next slide. The figure on your left shows you the modeled conduits that were in there, whether they're streams or pipes. And that was roughly the regional storm sewer system and portions of the local. But the area on your right shows you the extension of the model itself. And most of the storm sewers within the study area were added. And since the community had very good records of the different drawings, and anytime we found any areas that we looked like we needed assistance, they were able to quickly find those and share those with us. So it was a very good coordination effort between us and the city to try and get all this information in. Next slide. So right now we have 3 different monitors that are currently located in this service portion of the service area, collecting data and using both the district rain gauges and that gauge adjusted radar rainfall data. We're currently nearing the end of our model calibration. And from that, we'll define the different problems and then different types of solutions. And as I mentioned before, since this area was generally developed prior to stormwater control measures, some of the challenges of this area being very flat, very impervious, and having poor drainage soils, it looks like the storage alternatives are going to be the most beneficial to this area. And there's 3 general types that we're looking at. The first one are some conventional inline basins, which are the ones you typically think of. But in order for those to have the best application, you need to have enough elevation so you can allow ponding without causing problems into the upstream areas. Another option is the conventional offline basins, but in order to do that, you need to have enough area that you can divert the water from the storm or from the streets and storm sewers. And once again, with a very developed area like this, these are very, there's limited areas where you can do that as well. And the one that seems to have the most application and probably the most benefit, but also might be the most complicated and costly, are having some of these decentralized underground storage or bioswales. But with the imperviousness that we have and with the public right-of-ways that we have, it looks like these might have the best application. And once again, one of the reasons why we went to such a high level of detail. So as we proceed with these different alternatives, and we'll share these with the community, this might be a good thing to give you an update on the next spring Watershed Advisory Committee. Next slide. So with that, I'll answer any questions that there might be.
I see none noted, George.
Okay. Well then, I think the next slide will be handled by, is it Mike Blair who's here for the master plan update?
That is correct, George. So thank you very much.
Great, thank you.
Well, good afternoon, everybody, and thank you for allowing me to present an update on the stormwater master plan and study that's going on with the Chagrin River and the Lake Erie direct tributaries area. One of the photos I wanted to share with you in this first slide is basically a photograph that was taken in March of 2020 of the flooding that occurred in University Circle, which is associated with the Brook subwatershed. What I'll be doing is actually showing you in a few slides here how we were trying to mitigate some of this flooding while we were doing the master plan study itself. If we go to the next slide. So the first thing I'd like to do is give you an overview of the stormwater master plan studies that we've been doing. This actually gives you a status report as of the first of this month. At this time, we've actually completed 3 of the 4 master plans. Those include the Cuyahoga River South, the Cuyahoga River North, and the Rocky River. Those are at 100% complete. And the master plan that you'd be most interested in, the Chagrin River and Lake Erie Direct Tribs master plan, at this time we're 98% complete. We've completed all the data collection, the model runs have been completed. We've actually identified the problem areas in each of the subwatersheds. And at this time, we're currently reviewing all the draft reports, getting those comments back to the consultant so we can finalize these reports and get them out to each of our community members. So if we go to the next slide. As we've been going through each of the master plan reports for each of the subwatersheds, we've basically been totaling up the problem areas. And as you can see in this slide, basically we've come to a total of about 52 problem areas that have been identified in these 2 major subwatersheds. And you can see that basically they're kind of evenly distributed throughout each of the subwatersheds within the study area. We're still looking to get a total of the problem areas, both in the Brook and the Green Creek areas. So this total might change once we have those 2 subwatershed reports in. So if we can go to the next slide. So while we've been doing the Chagrin River and Lake Erie Direct Tribs study, basically we have also been trying to address some immediate problems that we've identified in the study area that we wanted to respond to quickly. The first one is as you saw in that March 2020 image, we had a large flooding event that occurred in University Circle. So once this flooding event settled down, we actually sent our field crews in that were involved with the master plan study to go into the culvert underneath University Circle and kind of see what was taking place there that might be contributed to the flooding that we noted in that image. What we found is that in 2 areas of the culvert, we noticed that we were getting blockages of debris from further upstream that were collecting in the culvert. The first one was a 15% blockage in the west barrel of the Brook culvert. Basically, this is kind of in an area near the art museum. But the major blockage that we were seeing was directly underneath Euclid Avenue in the culvert. There we were getting about a 40% blockage. And this material basically consisted of anything from small pebbles up to large cobble-sized material, almost about a foot and a half in diameter, that was settling out in these 2 areas. And these 2 areas where we noted where we get suddenly a large diameter of the culvert taking place and then a further restriction downstream. So these are 2 natural areas where this material had a chance to fall out and become an issue as far as a blockage. As a result of these 2 blockages, we've noted when we modeled this, that the overall result is that we were only getting less than a 5-year level of service in the culvert because of these 2 blockages. And you can see an example of the blockage in that lower left-hand image. If we go to the next slide, please. So this next image basically shows you what we did afterwards. So from December of 2020 to February of 2021, we hired a field crew to go into the culverts and remove this debris. And what they wound up doing is removing just under 2,000 cubic yards of material in these 2 blockage areas. As a result, we were able to increase the level of service in this part of the Brook culvert underneath University Circle from less than a 5-year storm event up to a 10-year storm event. So we were really happy that we can really increase the level of service in this highly urbanized and highly visited area of Cleveland, Ohio. And what I'd like to do is, if you take a look at the image on the right there, you can see what the extent of the flooding and the degree of the flooding was in this portion of University Circle before the 2 culverts were cleaned. And if we go to the next slide, you can see what it looks like once these 2 blockages were relieved. We were able to significantly reduce the amount of lateral flooding that was going on there. And in particular, along Martin Luther King Drive there near Case Western Reserve University, we're able to lower the height of the inundation there as well. So our next hope is that with the master plan being completed in this area, is that we can, we've come up with an alternative that could possibly allow us to raise this level of service even further from the 10-year storm event to the 25-year storm event, if we determine it's feasible to do this particular alternative. So if we go to the next slide, please. Another example of the work that we were doing early on while we were completing this master plan is that we were approached early on in the master plan by the village of Mayfield. They had a crossing at the Warren Park Drive that was starting to fail. And they were planning on replacing this crossing, but they knew that we were doing the master plan, and they asked us if we could take a look at this quickly for them to determine what would be the proper sizing of this culvert if they were to go ahead and replace it. They didn't want to go ahead and replace it if we were going to determine later on in the master plan that this should have been, the size should have been increased instead of putting something in it's the same as before. So what we did was we determined that we would treat Beecher's Brook as our pilot study for the overall master plan. And so we went in there, we collected our field data, did our surveys, our cross-sectional surveys of the creek, got our information of the condition of the culverts and the crossings and such. And we went ahead and we modeled this portion of the Beecher's Brook to basically size that culvert. And what we really found out is that this culvert, in terms of the high flows and such, was undersized. So we made a recommendation to the village that they actually go ahead and increase the size of that culvert to help relieve some of the flooding that was going on here without introducing additional flooding downstream. So if we can go to the next slide, please. So as a result, what we were able to do is recommend to the village that they replace that double-barrel culvert at Warren Park Drive with a 6-foot by 16-inch or 16-foot rectangular box, and that would take care of their concerns with Warren Park, and they could go ahead and replace that culvert. In looking at further upstream, we did identify 2 areas with possible where possible property acquisitions would be favorable to allow us to expand the floodplain and address some of the areas where we need a little bit of storage and we need to slow down some of the flows that are going through this neighborhood. And also where we do some channel improvements in this particular portion of Beecher's Brook. So we've come up with this this alternative. The village has already informed us that not only do they want to move ahead with the improvement to the Wharton Park culvert, but they also want to improve the culvert up at North Woodland Drive. So we're already taking our master plan findings, working with the city to try and address this some of these issues early on, even before the master plan is completed. So this was a nice collaboration between us and the city, and we're looking forward to moving forward with this particular project. Next slide, please. So where we'll go next with this master plan is that once we have the reports in, we're going to take a look at all the preferred alternatives that have been recommended by the consultant. We'll start the nomination process of getting these nominated, getting them validated that this is what we're truly seeing when we talk with our other divisions. And then we'll start scoring and prioritizing these various alternatives so we can start getting them into design and eventually into construction and moving forward with that. So if we can go to the next slide. Now, some of the alternatives that we'll have that we've already noted in the Chagrin River and Lake Erie direct tribs turned out to be very large projects, which either have a large complexity involved with them. They involve a large number of either building, transportation, or utility assets that are being impacted, or they have a huge cost associated with them, where it makes sense that we would take these to advanced planning. And when we take these to advanced planning, what we're trying to do is take these potentially cost prohibitive projects where it would just be too cost prohibitive to do it all at one time, and see if we can break these things down into preferable alternatives, into manageable projects that can be phased over time and be able to get these projects completed. Another thing that could have an effect on these projects where the advanced planning would be a preferable option is one where we have a large number of property acquisitions or easements that need to be acquired for that project. If we can break them down into more manageable projects, it makes the acquisition and easement procurement much easier. And this also might help us when we start considering that we have outside stakeholders that we want to work with as well, either the communities themselves, other entities such as, let's say, the Cleveland Metro Parks, the county, the U.S. Army Corps. This is where we want to be able to understand who the stakeholders are and break these projects down so that we can make them easier to coordinate with those various stakeholders. Alrighty, if we go to the next slide, please. So again, I've brought this up in previous WAC meetings, but I want to reiterate that, you know, as we've done these master plans, especially with the Chagrin River and Lake Erie Direct Tributaries project, we've collected a lot of data that we think would be valuable to you. George mentioned in his presentation that we've modeled each of these subwatersheds, and those models are living documents, and they're available to you upon request. And we'd like to work with you so that we can maintain those as living documents so we can update them as need be. Of course, we have information about all the culverted streams that we and video that we can make available to you, our inspections of all the crossings and bridges and such. And then we also have the spherical imagery, basically the Google stream view of all the watersheds that we'd be happy to make available to you as well. So in summary, at this point, we're nearing the end of the master plan in this study area. We expect to have the reports done by the end of November, possibly early December. And then once we have these reports done and we have the community reports done, I'll be working with Jeff to meet with each of the communities and sit down with you and show you what the results of the master plan are, show you what the preferred alternatives would be, and start talking potentially about next steps that we'd like to take place in each of your communities. So in the meantime, while we're finishing that up, if you have any questions, if you have any concerns, feel free to reach out to myself or especially your team leader, Jeff Jowett, and we'd be happy to respond to you and get back to you. And with that, just check to see if there's any questions.
Yes, Mike, Tori asked, what caused the flood in the first slide? Was it due entirely to heavy rainfall or had additional contributing factors played a role into that flooding?
A lot of it was just a major inflow. I apologize for forgetting what the storm event was in that particular area, but it was a mixture of a large amount of rain in a very short period of time. It's almost potentially like a microburst. And then we have these blockages going on in these two portions of the culvert taking place.
Thanks, Mike. That was it for questions.
All right. Well, again, everybody, thank you very much for your time. I appreciate it. What I'd like to do now is turn over the presentation to our next presenter. Ann Roberto, who's one of our Stormwater Inspector 2s with our Stormwater Inspection and Maintenance Group. And with that, Ann, take it away.
Thanks, Mike. So I'm Ann Roberto, Stormwater Inspector 2 in the Swim Department, and I'm going to give a brief inspection and maintenance update and overview of our demolition services. So first I'll discuss the inspections that we've covered this year in the Chagrin and Lake Erie tributaries. In the Lake Erie tributaries, we performed 190 inspections since January on streams, crossings, culverts, basins, and our building, transportation, and utility assets. 157 of those inspections were performed by SWIM, and the remaining 33 were performed by other responsible parties such as ODOT, the county, Metro Parks, and railroads. Next slide. In the Chagrin River watershed, we've performed 70 inspections since January, with 49 of those being performed by SWIM and 21 being performed by other responsible parties. Recently, we have shifted our focus towards culvert inspections in the chalet watersheds with those stormwater master plans coming in. And some of you have probably received some of our inspection reports. So the SWIM staff has performed culvert entries, and we also utilize the stormwater master plan PACP reports and CCTV footage to speed up our inspection process. The culvert inspections help us to inform and prioritize the culverts that are most in need of maintenance and repairs. And those repairs are prioritized based on the material deterioration and potential threats to nearby infrastructure. So the example featured in the photos is a culvert that's parallel to Cedar Road in Beechwood. And it's a CMP culvert that was previously lined, but the bituminous coating has deteriorated along the invert, exposing the corrugated metal with perforations. And there were also local tap break-ins that were defective with soil visible behind them and voids. So this was rated a 4A ODOT, and that is considered poor condition. And another example we have is a culvert in Cleveland Heights. This inlet's behind Cumberland Pool and outlets behind the rec center. The downstream section was previously repaired due to a partial collapse in May of 2018 behind the rec center. This culvert is a concrete box that transitions to a corrugated metal pipe arch with a paved invert. And the concrete along the invert, as you can see, has fractures and uplift, and there's also large holes along the invert allowing water to infiltrate. There was also spalling with surface reinforcement visible at the crown, and the downstream section has perforations with soil visible in the corrugated metal. So this one was also rated a 4A based on ODOT standards, which is poor condition. So now I'm going to quickly discuss the maintenance that we've performed this year. In the Lake Erie Tribs, we've completed 30 sediment and debris projects, removing 739 cubic yards of debris and 20 cubic yards of sediment. We completed 2 other projects, which included tree removal and some concrete patchwork on the U.S. Army Corps flood control channel in Cleveland. In the Chagrin River watershed, we've completed 3 sediment and debris projects, removing a total of 105 cubic yards of debris, and we completed 1 demolition project on Gates Mills Boulevard. Next slide. So this is just a little example of some debris that was removed from the 9 Mile Creek siphon in Bracknell after a larger rain event. We perform debris checks at the siphon and our debris racks quarterly and after large rain events to evaluate maintenance needs. Next slide. So here's another example. This is the U.S. Army Corps concrete flood control channel along Euclid Creek in Cleveland. A customer called us for some trees that came down in the channel, and we went out and removed a total of 40 cubic yards of debris. So now I'm going to discuss our demolition services. So property acquisition is a critical part of implementing stormwater projects for the district's regional stormwater management program. And most of the acquired properties are occupied by existing buildings and other infrastructure, which are required to be demolished prior to implementing a stormwater project. At the start of the stormwater, can you please go back? So at the start of the stormwater management program, demolition services were contracted out, and the Cuyahoga County Land Bank had previously handled our demos. But in 2020, the SWIM group took over the property acquisition demolition program. And a contracting program was developed for asbestos survey, abatement, and property demolition services. So this photo just shows a home that was demolished in Pepper Pike on Gates Mills Boulevard. Next slide. So the asbestos survey and demolition contracts were awarded this year and began in the spring. And removal has been prioritized based on how long the site has been vacant and project timelines. So this photo shows the recent demolition of a home on Forest Overlook Drive in Seven Hills, which was close to an eroding stream bank and is part of a planned construction project. The home foundation and driveway were removed and the site was graded and reseeded. So far this year, 4 homes have been demolished and 3 are currently in the process of being removed. So if anyone has any questions, I'll take those now. And if not, I'll hand it over to Tony Calvledge, the stormwater construction manager.
I think you're good, Andy. Any questions?
Great, thanks, Annie. Like Annie said, I'm Tony Calvledge, a stormwater construction manager. We're going to give you an overview of what we're working on stormwater design and construction wise. And first, we'll talk about the design component we're undertaking. The Baldwin Creek Relief Culvert at Storms Drive. This is in Parma. There's a basin upstream of this that needs to get better conveyance through it. And so we're entertaining putting a relief culvert down the street, down Storms Drive, which should increase the conveyance. And we're also looking in the future to do a basin expansion project there also. So residents of that neighborhood should be able to realize some flood risk mitigation because of this effort. Big Creek flood reduction. This is near Sprague Road in North Royalton and Parma. There's an undersized culvert, which is the top right picture. You can see the small culvert. So we're going to upsize that culvert underneath Sprague Road. And then there were 2 residential structures that were demolished previously on this parcel. And now we're going to create a more naturalized stream channel through this area with floodplain access. So that should really be a benefit to that flow area. A similar story here at Pepperloose Creek, culvert replacements and rehabilitations. This is Gates Mills Boulevard in the city of Pepper Pike. We got undersized culverts, failing culverts, causing road flooding. You can see in the picture on the right. So this will be a definite benefit to this area also. We've been talking about culverts. Here's another culverted streams rehabilitation. This isn't just a culvert that would go under a road or a crossing. These are culverts that go under sections of city for a long ways. This project in particular is looking at 3 different culverts. We'll analyze the different repair methodologies, be it we line the pipes, replace the pipes, okay, around $1.5 million worth of work for the construction estimated here in Garfield Heights. Similar to that, here we see a long list of culverts that need rehabilitation throughout the service area. And we're trying to associate $1.5 million annually to rehab these assets. We're looking at rehab procedures, daylighting procedures, anything we can to maintain our underground infrastructure beneath the city to make sure the public isn't affected by failures or flooding caused by these culverts and their deterioration. This is a beautiful picture of a finished project on Beecher's Brook in the city of Pepper Pike. Next, we'll talk about construction. And this is a recently finished project at the Rocky River. It's in North Royalton, right at Ridge Road. The before picture on the left-hand side, you can see this stream flow up against the road with a failing guardrail. A typical fix for this would be to drive some sheet pile next to the road to protect the road from the stream flows and its erosion. We've taken an alternative approach here. We've moved the stream away from the road, giving the stream room to flow and flood and do what it needs to do, room to breathe per se. If we keep these two utilities separate, being the two utilities being the road and the stream, one conveys traffic, one conveying storm flows, both are needed, but both need their own space. So both should be able to live harmoniously together in this newly created space. Another recently finished project, this is Pepperloose Creek. It's a stabilization near Lander Road. There was a residential structure here before. We've removed it. You can see in the before picture that there was very entrenched stream flow coming through this area. We've widened out the channel. We've created a riffles and pools alignment. Okay, and we've also created floodplain in this area. And so much more naturalized environment with plantings should give this stream enough room to access its floodplains and carry its flow regime through this area without causing any problems or further degrading itself. This is an area of erosion on Mill Creek. You can see exposed utility here. Looks like maybe a future project might be needed here also, right? But that's all I have for you today. I'll turn it back over to Jeff Jowett if I don't have any questions. Thank you.
No questions, Tony.
All right, thanks, Keith. Jeff?
Thank you, Tony, and thank you to all of our presenters. We had some great information for you all today. Thank you for our attendees. Again, my name is Jeff Jowett. My contact information is right up here on the screen. And as always, we will be posting this presentation up on our website. The address is right there for you. And before we close out, I just want to acknowledge a couple of things. We want to congratulate Watershed Programs Director Frank Greenland on his Lifetime Achievement Award that he received from the district for 33 years of service to the region and leadership. Also, we want to thank Mark Link, manager of our swim group, who will be retiring at the end of the year. I want to thank you, Mark, for all the wonderful work you have done for the district, and especially with the stormwater program since it started, back in 2012, and all your work prior to that. So Mark will certainly be missed, but congratulations to him on his retirement. So I think we just got it in before 3:30 as I look up at the clock. So again, thank you for everyone that attended. Thank you to all of our presenters, and we will be in touch. Goodbye.